Hey gang, so it's time to do, this is the 3.4. So this is our triangle trigonometry with circles. So here we go. So the length of an arc. So remember the arc, get my notes out here. The arc is going to be like from here all the way to here. That's going to be the arc. And there's going to be more than one on a circle, but let's say we want to know the length of that arc. So here's just some reminders. The circumference of a circle, you already know this, I'm sure, is 2 pi r. The ratio of the angles, if we did a full rotation, would be 360. I'm going to adjust my, well, I guess it's okay, my camera. I feel like I'm down here like a snail. Anyway, degrees of the same, is the same as the ratio for the arc length. This is just some facts here. The circumference of the circle is this. The full rotation is 360 degrees. And the degrees is the same as the ratio for the arc length L, and we're going to use, that's an L, it's probably not the best font to use. The circumference is 2 pi r. Okay, so we're going to use that arc length as 2 pi r, but we're also going to use that as the circumference. So this gives us, if we were to derive this and put it in and do a lot of algebra with it and some math, we would come up with this rule that the length of the arc is theta over 360 times 2 pi r, okay, where r is the radius and theta is the angle of measure in degrees. So in this case right here, I don't think I have it on here, but if I went from here to here and I knew this radius, I would say from here to here, this angle right here, 2 pi times the radius, and then the angle divided by 360 would give me that arc length. We're just going to use that formula a whole lot. We're going to know different numbers in it. It's really quite easy if your algebra is pretty spot on. That's all this is going to be today. So you can watch the video if you want. You can pause me, fast forward me, mute me, and just let me write, because it's actually a really easy math lesson today. So I've got this down here because I have to get it close so I can read it, y'all. Okay, so a circle with radius 5 centimeters, I'm on this one right here, has an arc that subtends an angle of 60 degrees. Find the length of the arc accurate to 3 sig figs. So here's what we know. We know the radius is 5. And we know our formula here. We're going to say the arc length, we're going to call that L, equals theta over 360. So how much of the circle do we have? Times, and I'm going to use the x there, 2 pi r. I know r, and I know the angle is 60 degrees. Okay. So we're going to plug this in. L equals 60 divided by 360 times 2 pi, and we're going to plug in r, which is 5. Now, pause your video if you want to do that. I'm just going to give you the answer. You can do that math. The arc length is about 5.24 centimeters. And again, if you wanted to do that, just plug it in. You're going to see me doing a lot on that, like this video, because it's just basic algebra and it's basic calculator. Okay, here we go. Leeway and his friends are conducting an experiment on a pendulum motion. If the pendulum is 45 centimeters long, that's our radius, and transverses on an arc of 45 centimeters, there's our arc length, find the length through which the pendulum swings to the nearest degree. So think about it like this. A pendulum, I'm going to try and draw the shots. I know I'm going to butcher it. Okay. Okay. So the pendulum starts right here, and it swings, and it goes gong, gong. And this right here is, how long was it? The pendulum was 45. Okay. The angle that it makes, was a 45. It's kind of odd that they had those both be the same. 45-degree angle, right? Oh, wait. We don't know the angle. We know it, was it transversing? Oh, I can't read it. If the pendulum is 45 centimeters long and it transverses on an arc that's 45. So, I don't know that degree right there, y'all. Sorry. Okay. I know that it's going from here, girl, all the way here. I know that it transverses on this. So that means I know the length of the arc. So I'm going to say I know the length of the arc is 45 centimeters. I know the radius is also 45 centimeters. And it wants to know what's the angle. Now, I know mine looks like 180. It's not going to be that. I want to know what's the angle that it's going across. So, we're going to set it up. Theta over 360 times 2 pi r. I'm going to let you plug it in and then you solve it. So you're going to do 45 for L. You're going to plug in, you don't know what theta is, times 2 pi, and you know r is 45. Now when I solve this one, I got theta to be 57 degrees. So you solve it and see if you get that as well. All right, that looks a little blurry to me, y'all. I'm going to just focus that. Ah, that's a little better. Okay, here we go. Given that the circle has a radius of 7, so I'm going to go ahead, I'm going to jump ahead. I shouldn't do that, y'all, but I am. Is 7, and the arc of length 9 centimeters. So the arc is, again, 9 centimeters. Is subtended to the central angle theta, so I don't know theta. Find the measure of theta in degrees on the angle for which the pendulum swings. So it's kind of the same thing, just this one's just straight up. All right, this one you're going to work it just like this one. You're going to plug in what you know. Let's see if I can move that up some. Nope, it's not going to let me. Let me zoom out, move up. I'll move up that way. You're going to use your same formula right here. You're going to plug in your values. When I did this, I found that theta was 73.7 degrees. And I think, yeah, I had 9 equals theta over 360 times 2 pi times 7. And that's what I got. Okay. All right. So in IB examination, the formula booklet gives you the formula for the area of a sector. Now, when you're doing the area of a sector, that's just a portion of your circle. So in this situation, I kind of colored it in right here, but I'm going to color it in with a marker. If I want to know the area of that sector, I'm going to use this formula right here. It's going to be in your IB booklet, but that's what I'm going to use. And again, basic algebra here, guys. We're just going to know some facts, and we're going to plug in our answers and see what we can find, whatever's missing. All right, so given a circle, move that up. Given a circle of radius 5 and a central angle of 60, find the area of the sector for this central angle. Give the answer accurate to 3 sig figs. Okay, so I know that my radius of this is 5, and I know the central angle is 60. Okay, I've got a formula up there that I'm going to use. Area equals theta over 360 times pi r squared. And you know the area of a circle is pi r squared. So this is a pretty easy. How much of the angle do you need out of 360? And then pi r squared, because the area of a circle is pi r squared. Anyway, so I'm going to say that the area equals 60 over 360 times pi times 5 squared. All right, when I worked this, and I'm going to let you work it, you'll probably have it done by the time I write this out. 13.1 centimeters squared. All right, example 5. You can pause it, whatever you need. Students in a high school would like to create a shot put field. Oh, this was a really fun problem. Like, I really like this one. A shot put field with a center circle of radius 2. And anybody that's done track, you know these dimensions. So here's their circle. They want the radius of the center circle to be 2. So that means this is my center circle. So this radius right here will be 2. Okay. The second ring would have a radius of 4, and the third ring would have a radius of 6. I'm just going to like draw that so you can kind of see it. So this ring right here would be 2. The radius from here to here would be 4. And so you're thinking if I had that big circle, it would be 6. And then the radius from here to here, I didn't get it very good in the middle, would be 6. Okay, so you've got 3 circles on this. All right, where am I at? They need to plant grass seeds between these rings if the center angle is 45, so it gives it here, if this center angle is 45, calculate the area of the shaded region to the nearest square meter. So this is our shaded region. They want to know the area of this one. Okay, so if I wanted to work this one, couldn't I just say, or really I need the area of the big circle, and then I just need to subtract off the area of the little circle. So I'm just going to write, I want to take the area of the large minus the area of the small. All right. We know the area is theta divided by 360, and that's my daughter calling, and I don't have, hold on, let me go find a phone. All right, we're trading out cars. Okay, area of the large minus the area of the small. We need to have grass on this one. So we know that theta is the angle. We already know it's 45. So the area of the big one. So the big one, let's do theta over 360 times pi r squared minus, and I'm just going to actually, I probably shouldn't have put that here, but I did, r squared. Okay, so the area of the large circle. Now, when I look at this circle, and this one was kind of hard for me to visualize, I've got this big circle here, but I'm only doing this little piece right here, this section. So I'm only going to do the area of this right here, right? And since I only want the area of this circle, think about it like a donut, like it has a hole in it right here. And I'm only doing this 6. I don't need to do the whole thing and then subtract off this. I could do it that way, but I'm going to do this one right here. So I'm going to do that. The angle is 45 over 360 times pi. The r for this one's going to be 6. And then I'm going to look at just this little one right here, and I'm going to subtract off this little one, which is going to be minus, again, 45 over 360 times pi. But this time my radius is going to be 4 squared. Let's double check my math on here. Okay, so here's what I got when I did this. I got 14.137166 minus 6.28318. I'm going to say those one more time in case you didn't get it. 14.137166 minus 6.28318. So when I got this, I got approximately 7.85398 is the area of the shaded. And it sort of perplexed me when I first did this one. Like, why did I not do 2, 6, 12? Why didn't I do 12 and then subtract off 6? It ends up being the same thing if you do it that way. So I'm going to pause and I'm going to see if I can put it on my calculator real quick because I don't want to waste video time for that. Okay, so I was wrong. I sat there and worked it like 20 times. It does not work that way. And the reason why, I was going back and I was looking at the problem above. Given the radius of a circle is 5, you're given that this outside radius is 6. Not like from here to here. You're only given this right here, that it's 6. And then you're given that the radius of this circle is 4. So I guess we have to think of them like 2 independent circles, and that's why it doesn't work. I sure was thinking that we could say the whole thing was 12, and then just take 12, the area of this for 12, subtract off this little piece right here, and what was left would be that, but it does not work out. I have tried it numerous times. And I think it's because they tell you the area, or the radius of this is 6, the radius of this is 4. So if you take the radius of this one, the big one, minus the 4, then it works out. Oh, you know what? I think I just realized what we did wrong. Ah, I wonder if y'all did. This is great. I love when I'm making these and I like have these revelations. Okay, that's where I messed up. If the radius of this is 2 and the radius of the next one is 4, then from here is 2. 2 more makes, oh my gosh, Mrs. Dean, really? And if the radius from here to here is 6, then from here to here, if this is 2 plus 2 is 4, then this one's 2. So I kept going, why is that not working? The whole thing is 6, so the big one, which is 6, minus the little one, which is 4. 2, 2, and 2. Oh, y'all, sorry, it's been a long time. But I still like this problem. Now it makes a whole lot more sense. Sorry for that confusion. When you plug it in, now it makes, oh my goodness, so much more sense. I'd go back and redo the video, but I've already got too much on it. I don't want to mess with it. I know it's only 15 minutes long, but no, I'm not going to do it. Okay, number 6. The diagram shows a circular, The diagram shows a circular sector of radius 3 centimeters and a central angle of 110. Find to the nearest square centimeter the area of the shaded segment. Oh, this is going to be good. Okay. So the area of it, so this little area right here. So this is just this little sector. Remember, when we go to do our formula, we're going to find the area of the whole sector right here. The area of a sector is, so remember when we go, area is going to be theta divided by 360 times pi r squared. That's going to give us this whole, like if I were to shade it in, the whole thing. So what I need to do is take the area of the whole thing and subtract off what? Yeah, that triangle. Oh, this is going to be a good one, y'all. I can't get my paper to stay. Stay, paper. Okay, so I'm going to take the area of, let's say, the whole sector minus the area of the triangle. We'll call it AFE. AFE. Okay. All right. So I know you can do the sector. You know it's theta over 110 times pi. What's the radius? And hopefully you're looking and go, oh, well, the radius would be 3, right? It would be 3. So if this is the radius, you know that this side is 3 as well. To find the area of the triangle, when you know a triangle, in order to find the area, you have to use that formula, 1/2 AB sine of C. And remember, in order to use that, you need to know the side, the angle, and the side, which you do. AB sine of 110. Now, you're going to plug all that in. Over here, you're going to have theta over 360 times pi r squared. Theta is 110 times pi times 3 squared minus 1/2 times 3 times 3 times sine of C, which is going to be 110. I'm going to tell you that the area of the shaded, I got 4 centimeters squared. Area of the sector, I got 8.6393 for that. And the area of the triangle, I got 4.2286. And when I subtracted those, I got 4 centimeters squared because you had to round it to the nearest square centimeter. All right, my daughter just walked in. All right, on to example 7. Find the radius of the sector. Given that the angle of the sector is 110 and the area is 1,640. All right, I'm going to give you an equation to use to this. You're trying to find the area of a sector. So area equals theta over 360 times pi r squared. What do you know? You know the area. You know the degree. And you're trying to find the radius. You know the area. You know the degree. Surely you can plug that in. Okay, so I'm going to tell you that I got that the radius, after doing a lot of math, was 41.333 or 41.3 meters. All right, on to the next one. You can work that one. These are all so easy. The diagram shows a circle with a shaded sector. Find the length of the arc. Okay, so remember when you're trying to find the arc length, we do theta over 360 times 2 pi r. That's our arc length. So if you look at the picture, you're going to be able to see the radius. I'm just going to put a box. You can put that in there. The radius, you're going to be able to see theta, which is the degree. And the rest is just finding the arc length. All right, so the radius is 6. Theta is 135. The arc length, when you saw for this, I got 14.1 centimeters. Or, and you might be like, wait, This one, it's a cognitive question, and they actually want the answer in terms of pi. Okay, so if you keep it in terms of pi, I got 9 pi over 2. How do you keep it in terms of pi? Just don't multiply the pi in there, and then you'll get in terms of pi. All right, number 9. AT is a tangent to the given circle. OA is 12 centimeters, and the radius of the circle is 6. So I took this and I kind of labeled everything. Find the area of the shaded region. Oops, sorry. Okay, so you're trying to find the area of this shaded region, which is actually the kind of like the triangle, sort of, right? Okay, so here's what I'm going to say. AT is tangent to the given circle. So AT is the tangent line. So think about it. You could extend this out. It's the tangent line. What you may not know, or you may not remember, let me focus that a little bit. Well, there we go. Is that tangent lines are perpendicular at the radius. So this right here is a right angle. That might be something you didn't know. OA is 12 centimeters. Okay. And so that's this whole side over here. This is 12 centimeters. That whole side there. And let's see, AT is the tangent. And we know that the radius of the circle is 6. So we know that the radius of the circle is 6. And I know something else, don't I? I do not know anything else. Okay, that's all I know. So how can I solve this one? Well, if I look at it, if I knew the area, I'm just going to kind of color it in. If I knew the area of the sector right here, couldn't I take, and I'm going to do this whole big thing here because I'm so visual. If I knew the area of this great big triangle and I subtracted off the yellow sector, all that would be left is like the shaded area, right? So let's take the area of the big triangle. It's the big right triangle. And subtract off the area of the sector. And we can figure it out. Now, I'm going to let you do the math on this, and I'm going to let you figure this out. And I'm going to tell you that I got, let's see, where's my final answer? Find the area of the shaded region. All right, so here's what I got. I got the area of the shaded was 18 square roots of 3 minus 6 pi, because this is a cognitive homework question, and they want the answer in terms of exactness. They want it to be exactly. What exactly is the area? When they say exact, they want it like this. If they say 3 sig figs, you can do decimals. All right, so let me help you a little bit. For the triangle, I could figure out theta right here by using right triangle trigonometry. So I know the hypotenuse and I know the adjacent. So I could figure out theta simply by doing the inverse cosine. So theta would be the inverse cosine, I kind of put that in the wrong spot, of adjacent over hypotenuse, or 1/2. Some of you already know that as a special triangle. And I got 60 degrees. So I know the angle. 1/2 base times height would also give me the area of that triangle. I don't know this side over here, though. I don't know the height. So I'm going to call that height x. So area of the big triangle would be 1/2 base times height. I don't know it, right? So I need to know the height right here. So that would be my good friend Pythagoras. It's a right triangle. So I could say that x squared plus 6 squared equals 12 squared. Ooh, 12 squared. There we go. X squared equals, let's see if I already worked this on my paper anywhere. I did. Equals 108. x equals the square root of 108. Now, this is where simplifying radicals is going to come into play. Some of you who had me, you will remember this. If you didn't have me, you might not remember how to simplify a radical. We did something called the birthday cake method, and that was where you start dividing this and you create a birthday cake. You only divide by prime numbers. So this is an even, so I'm just going to divide by 2 as many times as I can. Okay, 2 goes into 108. I'm going to say 5, 10, 2 goes into 8, 4. I'm going to divide by 2 again. 2 goes into 54. 2 times 14, that would be 7. 2 won't go into this, but I can divide by the next prime number, which is 3. 3 goes into 27 9 times. I'm going to divide by 3 again. It goes into 3. Divide by 3 again, and we get a 1 on top, or the birthday candle on the birthday cake. That means that if I take the square root of 108, it is 2 times 2 times 3 times 3 times 3 times 1. And then I circle, because it's the square root, I circle the doubles and bring them out. Circle the doubles and bring them out. So I'm going to bring out 2 times 3, and underneath the radical, I still have 3 times 1. So that would be 3. 2 times 3 is 6. So this becomes the 6 square roots of 3. So the square root of 108 is actually 6 square roots of 3. I can do the area of the triangle. So the triangle would be 1/2 the base, which is 6, times the height, which is 6 square roots of 3, minus, and I need to do the area of the sector. So the sector, it's not quite as hard. I don't know that right there. So I know, let's see, what do I know on here? I know the angle is 60. And you know what, let me write it over here. Area of a sector is theta over 360 times pi r squared, right? So let's see if we can do that. We would do theta, which is 60, divided by 360 times pi. Oh, we do know r is 6 squared. There's my formula. 1/2 times 6 times 6 times the square root of 3. 6 times 6 is 36. Cut in half would be my 18 square roots of 3. And then 60 divided by 360. And then times 36 pi. And I got 6 pi. If you were to use, I don't think I even did it. I didn't even do it with decimals on that one. I think because the cognitive question on that one requires you to do that. Okay, after this you are on cognitive. Pay attention on that because a lot of the cognitive ones we already did in the notes. So anyway, thanks for watching, y'all.